Hello students, welcome to my YouTube channel. In this video lecture, we are going to start solving the new questions from Keith Williams' Weight and Balance book. The name of the chapter is Basic Questions, the very first chapter. Now this chapter deals with a variety of questions which are very basic in nature, formulae, simple definitions, simple numericals, etc. So let's start with question number 11 and let's look at each and every question. Let's look at the explanations. The true definition of the datum point is what? Datum. Now, in all your center of gravity calculations, you will always come across a concept called datum. So, datum is nothing but an imaginary plane. I will draw that datum here. It's an imaginary plane from which all center of gravity calculations are made or calculated. Okay. So, let's say this is the object in your aircraft. Okay, and you have to calculate the distance of this object from the datum. Okay, so all the distances of variety of objects in your aircraft, different objects in your aircraft, are calculated from a datum. So in this case, this datum is here. So the distance from the datum will be calculated. We call that arm distance. This arm distance and this weight or the mass of this object will be multiplied to calculate moment. Okay, so you are going to repeat this technique or repeat this procedure with all the weights in your aircraft. You are going to add everything and calculate the center of gravity. You will learn it. It's very easy. I'm also going to solve center of gravity based questions in new lectures that I will do. So you will learn how to find out center of gravity in those lectures. You will also find it out how to do it, and you will always do the center of gravity calculation uh, before every flight in your CPL training and even when you transition to airlines. So it's going to be a routine job. So this datum is an imaginary point plane from where these calculations are made. Second important fact, this datum can be located anywhere on the longitudinal axis of your aircraft. What is the longitudinal axis? An imaginary axis passing through the nose of your aircraft like this and passing through the nose and tail of your aircraft. Okay, so this datum can be anywhere on the longitudinal axis. It can be inside your aircraft, it can be altogether outside your aircraft as well. So this is another important fact. Next, so definition of datum. The CG relative to the nose of aircraft, no. A reference point from which CG calculation are made, yes. A reference point which is used when calculating CP, center of pressure, no. A point within the fuselage through which all the axis of motion pass. Okay, so that is also wrong. So Bravo is the right option. The center of gravity range is determined by whom? Manufacturer, ICAO, aircraft operator, okay, National Aviation Agency like DGCA, whatever. So the correct answer is option A. Now this is your aircraft. Okay, there are two important points related to this. This is your aircraft. The manufacturer of this aircraft will specify or prescribe the forward limit of CG and the rearward limit of CG. So the center of gravity of this aircraft is permissible to move or is permitted to move within this range. Anywhere within this range, the forward range and the forward limit and the backward limit. This range, this total range is determined by the manufacturer. Okay. This question has asked about center of gravity range. So we have selected option A. If the question had asked only about center of gravity, who calculates the center of gravity or who is responsible for the calculation of center of gravity, then you would mark option delta, aircraft operator. Okay. So the operator of aircraft is responsible for calculating the center of gravity before every flight. Okay. When you start your flight training, it will be your responsibility to calculate the center of gravity of before every flight. What items are included in variable loads? Now, variable loads includes crew, crew baggage, food, water, toilet, chemicals, etc. Okay, so all optional equipment. So uh, variable loads, passengers, no, passengers are a part of payload. All people are internal load, no, not all people, just the crew. So Bravo also eliminated. All passengers again eliminated. Delta is the right answer. Crew, crew baggage plus removable equipment. Okay, next. The correct formula for calculating the CG position is, so the formula is, like I said before, mass into arm distance. Arm distance is nothing but the position of center of gravity is equal to moment. So now this can be cross multiplied and then select the most correct, select the correct option. This is the main formula. Now the option can be arm distance equals to moment upon mass. So select this option if it's there. If neither of them is in the option, so you will select an option which has maybe, let's say, mass equals to moment divided by arm distance. Okay, so pay attention, it will be confusing, so you will have to be attentive and careful. Next, what is dry operating mass? So dry operating mass is basic empty mass plus variable loads, or basic empty mass plus variable load is dry operating mass, or zero fuel mass minus traffic load is the dry operating mass. Either way. Okay. Second, there is also a third way. Takeoff mass minus useful load can also give you uh, dry operating mass. The fourth way, operating mass minus takeoff fuel can also give you dry operating mass. So, zero fuel mass minus variable load, wrong. It's minus payload or traffic load. All up mass, meaning takeoff mass minus fuel load, no, it's all up mass minus useful load. Basic empty mass plus disposable load, no, it's variable load. Basic empty mass plus variable load. So delta is the right answer. Which of the following best defines the basic mass of aircraft? The basic empty mass. The zero fuel mass minus passengers, no, that is DOM. Mass of aircraft minus passengers or crew, uh, minus passengers or crew, again no. Mass of aircraft with its basic equipment but no fuel or oil. The mass of aircraft with its basic equipment and standard quantities of unusable oil, fluid, fuel, etc. So delta is the most suitable option. Okay, next. Aircraft loaded with fuel tanks and fuel tanks full capacity, passengers full capacity is only within its takeoff mass limits when temperatures are above ISA, meaning hotter than ISA, warmer than ISA, is sometimes but not always within takeoff limits, can never be within takeoff limits, is always within takeoff limits. So option Bravo. Now if you load your aircraft to its maximum fuel tank capacity as well as maximum passenger capacity, the aircraft, the weight of this aircraft will be its maximum. It will achieve or it will attain its maximum structural takeoff mass value. But always remember there are two types of takeoff mass values. There is one maximum structural takeoff mass, which is a fixed quantity given by or a limit imposed by the manufacturer. And the second one is performance limited takeoff mass, which you calculate for that particular day, that atmospheric conditions, right? So outside temperature conditions, density altitude, pressure altitude, obstacles in your climb path, the runway distance available for takeoff, landing, etc. So all these factors will bring forth or a different takeoff mass limitation called performance limited takeoff mass. So the ultimate takeoff mass value that you are going to select and load your aircraft with should comply or should follow or satisfy not only the condition of maximum structural takeoff mass imposed by the manufacturer, but also the limitation imposed by the outside temperature conditions, the runway conditions, the obstacle conditions, etc. Right? So it won't be always that the weight of your aircraft, the maximum weight of your aircraft will be within its takeoff mass limit. Sometimes the weight of your aircraft, the weight that you think will be appropriate to take off with, may not be within the limits of performance limited takeoff mass. Okay, so it's sometimes but not always. You have to also consider the performance limited takeoff mass. Okay, the conditions or the factors that hamper the performance of your aircraft, like the takeoff distance, the rate of climb, etc. Okay, so Bravo is the most appropriate option here. So this concludes our lecture. I hope you have understood all the questions I have answered and explained in this video lecture. Let me know your doubts, comments, feedback in the comment box of this video lecture. I request you all to subscribe, hit the like button and share this video with all your friends who are also preparing for the exam.